Okay, so here's a series, all right? One path, all on or all off. Look at the parallel circuit. So you see this junction right here? This current can go down this way, okay? And then go and back. That's one path, one. Or, look at this. Or it can go this way, okay? And then go, and then turn this one on, and then back. That's two. Okay? I'm going to use different colors actually. So here is the second path. It went this way and then back. So now this one is on, right? Let's actually talk about the green line first. So the green line. When I use the green line, I'm going to call this one R1 and R2. What happens to R1 and R2 if I use the green line? R1 is on and R2 is on. That's one path. I'm going to call it path number 1. Okay? This dark pen, the black ink, okay? That's another ink. So what happens when I use this one? Is R1 going to be turned on?
Yes.
R1's right here. Did it turn on? Did it go through it? No, it didn't. No, it didn't. It didn't go through the monster fangs. It didn't. So here's the line. It went through the wire. It's going to take this wire right here, through this wire, and then through this wire here. And then R2 is on, R1 is off.
You mean by the last line or by the middle line?
I'm using this middle line. It's going to take this line, okay, this wire, okay, and then here, I'm just using the arrow. I'm just drawing the arrow, but it's actually using this wire here. So it did not go through R1. It didn't go through. It has to go through R1 for the current to actually turn on R1. It did not get there. Do you understand? It has to go through. Okay, so the current went through this wire,
The green one, okay.
the black pen, and then it's gonna go through this wire. So this wire has current, this wire has current, and then this R2 is on, and then back to the battery. R1 is off.
Okay, so R2 is on and R1 is
Now we're gonna take another path. Okay, so that's path number 2. Path number 2 is the black pen. And then what's one more path? So I'm gonna go from positive. So I'm still gonna take this, okay? And then I'm gonna go down all the way. See that? And then I'm gonna go all the way here and into R1 and to R2 and then back. So that's path number 3. So this pink line is R2 is on, R1 is off. Is there a way that R1 can be turned on but not R2? No, there isn't. There's not a way. So I have to go through R2 to go back home. That's right. So this is a parallel circuit. Okay. So in this example, there are 3 paths. Okay. So if you have more than one path, a parallel circuit has more than one path for the current to go through. Okay, it's got more than one path for current to go through. So then it can go back to the power source because it has to go back to the power source. So that's how we know if it is a parallel circuit. Okay, so again, we're comparing series and parallel. So just to finish this off, in a series circuit, what do we know so far? How do we find the total resistance?
Only one path.
Only one path. And how do we calculate the total resistance?
Plus.
R1 plus R2. In a parallel circuit, it's different. It's actually the reciprocal. So to find the total resistance, we have to go 1 over RT equals 1 over R1 plus 1 over R2 and so on, depending on how many resistors you have. So let's actually do an example right now, okay? Do an example here. So what? Give me a number. 5. Okay, so this one is 5 ohms and this one is 10 ohms. So I'm going to do the same thing here. 5 ohms, 10 ohms. Okay, so in the series circuit, What is the total resistance? 5 plus 10 is 15 ohms. Okay, 15 ohms. So you see, the total resistance is higher than the highest resistor, always, because you're adding it up. Let's take a look at the parallel circuit. You go 1 over RT, get your calculator. This is going to be 1 over 5 plus 1 over 10. Okay, can you give me that number when you do that? Just the number when you go 1 over 5 plus 1 over 10. What do we get?
3 over 50. No, 3 over 10, yeah.
Yeah. Give me an actual number. 0.3, repeating. 0.33. Just 0.3, okay. So 0.3 is actually 1 over RT. We don't want 1 over RT. So to get the RT, you're going to go 0.3 and you're going to inverse that to the -1. So that means 1, which is the same as 1 over 0.3, and that will give you the total resistance, which is 3.33 repeating ohms. Look at that.
How do you put that together? Like 3
Yeah, this 0.3 is actually 1 over RT, right? So in order for us to reverse it, to find the RT, this is going to end up to be, if I were to show the step that's missing here, this will be 0.3 RT equals 1, right? So then RT is 1 over 0.3. So I'm writing on that other page. It's actually going to be an inverse. Look at the numbers though. I just want you to see the number. You end up with 3.33. That's the total. That's actually less than the individual ohms, isn't it? It's less because each one is one's 5 and the other one's 10. And then you combine them and then all of a sudden you get less resistance. So in a parallel circuit, the more resistors you have, the better it will be for the resistance. Unless you're going for resistance for your device. Okay, so that's the most important, most obvious thing that is different between parallel and circuit, parallel and series circuit. Okay, any questions so far?
Please can you again, R1 is for on and RT is on. Can you show me?
For this one here?
Yeah.
Yeah, so then the formula is this.
That's okay, I understand the calculation.
Yeah.
Just answer. The green on.
Yeah. So this is the main difference between them in terms of
The circular parallel.
why is it parallel?
No, just I want to know R1 on, RT is on.
Oh, okay. Okay, so if I were to follow just the green one,
Yeah, that's okay.
okay, here.
We didn't see that. Can you down?
Oh, so it comes out of the positive, right? It takes this wire. This wire, if the current is running through them,
That is the black one.
this is R1.
Okay.
So R1 is going to be turned on.
Okay.
And then it takes this wire, and then R2 is going to be turned on as well, and then it's back to the battery. So R1 and R2 are both turned on in the green line.
On the green.
The green line. That's path number 1.
So, but you show me the black one. It's okay.
So
Okay.
yeah, you see the black one now?
Yeah.
You see the black one is this line, and I just drew the arrow right beside it. It didn't go through R1. So R1 is going to be turned off in the second path.
But what about R2? Is not.
R2 is the black line. R2 is the black line. So I put the arrow here because if I drew the arrow right on the line, you can't see it.
So what I meant, no, in R2 it doesn't go by, how can I say on? R2
Because here, I'm going to follow my pen.
Okay.
I'm going to go this way, follow this line. Okay. It bypassed this.
Okay.
It went this way instead. It took a long way.
Okay.
And then it's going to go this way. So current. But it goes through R2. Yeah, that's on. But this one,
Yeah,
no.
that's,
Yeah. And then for the last one, see the pink one.
R2,
Yeah, same thing. It went a longer way,
yeah,
but R1 was completely missed.
yeah, okay.
And then R2 is only on.
But R2 is going by the circuit or it is
Yeah,
R2?
R2 is going to get the current. So this is just an extra wire.
I know.
This, yeah.
But the pink color is will be they didn't put by the
Yeah, the pink line.
yeah, it's go ahead and R2.
Yeah, it's only going through R2.
But they didn't pass by the circuit. It's a bit
That's right, it didn't pass by R1.
Okay.
Do you see it, Suad? Make sense so far? Adam, you're okay? You'll see more of these, okay? We're gonna see them as we go. Okay, these are the cardinal rules for parallel circuit. Okay, so in a parallel circuit, this is how we calculate the current. Because look at this, the current is actually split. Okay, so the current splits because it's taking different paths, right? Current splits because it has different paths. So the current will have to go that way or go this way. Okay, it has choices, just like you're like at the fork in the road. You can turn right or you can turn left in a parallel circuit. But in a series circuit, you have no choice, right? If the road is only going straight or left or right, that's what you take. So this one, the current can split. So when you find the total current, you're gonna have to add the current 1 plus current 2 and so on, because it will have to split. However, take a look at this one. I'm gonna draw a different diagram here. So this is what happens with the voltage. The voltage is the same. So the total voltage, okay, the individual voltages are the same. So same voltage as the VT. So it's different current, but it's going to take the same voltage. So this is what is the same in a parallel circuit. In a series circuit, do you remember what's the same? Current, okay? So I'm going to go back to the rule here. See, this is what's the same. The current is the same in series, different voltage, right? So I'm going to add this. You're going to get different voltage because it is going to go through it, okay? But in a parallel circuit, what is the same is the voltage. Current splits, that's right. Okay, so the last one, okay, we already looked at this one. It's reciprocal. So this is better written like that. In your calculator, can you guys take a look at your calculator? I'm going to show you a quick shortcut here so that you guys are not... You see here, you see the button that says 1 over x, okay? Or sometimes you see it as x to the negative 1. It all depends on your calculator. In this calculator, you have a 1 over x right there, or x to the negative 1. It depends on what calculator. Use that one so you're not going 1 divided by. So that's an easier way to go with this one. Okay, shall we do more examples? The more examples you see, the better it is that you're going to see this. This is, by the way, known as Kirchhoff's rule. Okay, so these rules, yeah, these rules are known as, oh, in your calculator, hang on. This is pronounced Kirchhoff. They used to be called Kirchhoff's laws, but that's not accurate because it's a rule. It's a set of rules, so it's Kirchhoff's rules. So in your calculator, this one here, so what yours is x to the negative 1. So when you do this, remember, all you have to do is go like this. 5, see that? Press that one, plus 10, press that one, equal sign, you get the 0.3, and then look, I'm gonna press it one more time, and there's your answer.
Good.
So it's a lot faster than going 1 divided by whatever.
It is ours.
Yeah, so I'm gonna give you guys the Kirchhoff's rules now.
Already at a bonus, like bonus, or this abbreviated at a bonus, right?
Which one?
3 or 4.
Huh?
This one, the last one.
the
Is it a name of person?
Kirchhoff's rules.
Is it
Yeah,
a-
that's the name. So the voltage being the same in parallel circuit, the series have the same current. Those are it's called Kirchhoff's rules.
Like Michael's law, Kirchhoff's law.
Yeah, that's basically what the person's name.
No.
Here. Oh, it's not having fun. Sorry about that.
So can we split it down?
Sure. Kirchhoff. Did you guys find that button in your calculator that will make you calculate things faster? Adam, there we go. Okay, so we're gonna do another example now.